What is this particular question trying to say, children? Determine whether the points are collinear. Now, if you are visualizing the sum, I have written there are 3 points and I have written the same 3 points over here. So for what reason I have written question twice? The answer is that whenever it is being questioned or asked to us what? Determine whether the 3 points are collinear or not. There are 2 answers for it. How many answers are there? There are 2 answers for it. One, with the help of distance formula, and the second is with the help of slope. Now this is coordinate geometry. Let me say what we had done in geometry. If the same question were to be asked to you, what do you mean by points are collinear? The answer would have been, if a single line passes through all the 3 given points, the points are termed as collinear. If the single line passes through all the 3 given points, the points are collinear. That's the geometric definition. We are into coordinate geometry. So the collinearity definition will differ from geometry to coordinate geometry. Answer are 2. One is with the help of distance formula, one is with the help of slope. One is with the help of distance formula, one is with the help of slope. Question arises. Sir, in exam, which one we are supposed to go with? If not given anything, most probably they will never ever give you. You are free to make use of anything. But if you ask me, sir, what is your choice? My choice is with the help of slope. Here I'm going to show you via distance formula. Here I'm going to make use of slope. So given an option to me, sir, which one you will go for? I shall go with slope. The reason you will get to know in the next 5 minutes or so. Let's start. So let me just write down over here. This is via distance formula I'm making you learn. This is via distance formula is what we are going to learn. And this is what we are going to learn via slope. This is via slope. Let's start. Now I shall write down to make you understand. First of all, I draw the diagram. So this is my A, this is my C, and somewhere here is my B. Not acting as a midpoint, mind you. A, 1 minus 3, B, 2 minus 5, C, minus 4, 7. So with the help of distance formula, you know what are we going to do, children? We are going to find out. I really don't know that whether the collinearity will be like this only or not. I really don't know whether it is ABC or ACB or CAB. Children, we are not aware. So if you want, I can say that let this figure not be there, because right now we are not in a position to judge who is between whom. B is between A and C, or C is between A and B, or A is between B and C. So if you don't want to draw the diagram, fine, it's very much okay. But what are we going to do with the help of distance formula, children? What are we going to do? We are going to first find out distance AB by using distance formula. We are going to find out distance BC by using distance formula. We are going to find out distance AC. So how many distance formula are we going to apply? 3. How many distance formula are we going to apply? 3. How many distances will we have? 3. AB, BC, AC. What next? Out of the 3 distances, what we have found out, right? Check which is the bigger one. I reiterate. Out of the 3 distances which we have found out, one is AB, other is BC, third is AC. Check which is the bigger one. Mark that as some equation. Which are the other 2 smaller one compared to the third bigger one? Sum up the 2 smaller one. Sum up, add them up. If summing up the 2 smaller, if it is equal to the third bigger, then the points are collinear. And if it is not, the points are not collinear. If the summation doesn't turn out to be equal, that means sum of the 2 smaller is not equal to the third one, bigger one, the points are not collinear. So let's start off it. Let's start off it by using distance formula. I have written let A, B and C in my question only, so that we can save some space. So by using distance formula, if you want, I'll write down then. If you want, actually the sum has to be written down in this way. Let A 1 minus 3, I thought I'll write down in the question itself, but fine. B 2 minus 5, which is x2, y2, and C is minus 4, 7, x3, y3. By using distance formula, first I'm making use of AB. So distance AB. distance AB. We are not writing the formula, we are writing direct answer. Under root of x2 minus x1 the whole square. So 2 minus 1 the whole square. Plus y2 minus y1 the whole square. y2 which is minus 5. Minus y1 which is minus of minus 3 which is plus 3 the whole square. 2 minus 1 square 1. That is square of 1 is 1. Minus 5 plus 3. Minus 5 plus 3 is 2. Square of 2 4. Square root of 5 or simply 1 root 5 units. That's distance AB. That's distance AB. Let this be equation number 1. Let this be equation number 1. Also, the second one what we find out is, we have gone and found out AB, now AC. BC. Now BC. Distance BC. Again, under root of, mild change in the formula, x3 minus x2. So it is minus 4 minus 2 the whole square. Plus y3 minus y2. 7 minus of minus 5. 7 plus 5 the whole square. Under root of minus 5 minus 4 minus 2. Minus 6 the whole square. 36. Square of negative is always positive. 7 plus 5. 12. Square of that. 144. Under root of 180. Shall be written as 36 into 5. Shall be written as 36 into 5. Square root of 36 is 6 root 5 units. Equation number 2. Distance BC. Distance BC. What I'm going to do is, I'm going to go for the third one. What is the third one? Distance AC. Also, distance AC. By using distance formula, again, direct answer. AC. y3 minus y1, minus 4 minus 1, minus 4 minus 1, the whole square. Sorry, x2 minus x1. And y3 minus y1, 7 minus of minus. 7 minus of minus. So 7 minus of minus is plus 3, the whole square. Minus 5 square, 25. 10 square, 100. Under root of 125, which we can say 25 into 5, which is 5 root 5 units. This is my equation number 3. This is my equation number 3. Now children, I just want, as I stated earlier, which one appears to be the biggest value? 1 root 5, 6 root 5 or 5 root 5? But natural, 6 root 5. So what did I say? Sum up the two smaller. If the summing up of or equals to the third one, the points are collinear. If it is not equal to, points are not. So what I will say, from 1, 2 and 3, 1 root 5 plus 5 root 5 is equals to 6 root 5. That is distance AB plus distance AC is distance BC. Is distance BC. Since sum up of two smaller is equals to the bigger, therefore points A, B, C are collinear. If they happen to ask us, write down under what collinearity, that means who is lying between whom, the betweenness question, which point lies between the other two? The answer is, who is the bigger one? The bigger one is BC. So let me draw the diagram. The bigger one is BC, which is 6 root 5. Then comes AB, 1 root 5. Then comes AB, which is 1 root 5. Then comes BC, which is 5 root 5. Together is 6 root 5. So if somebody has to ask me the collinearity in the question, I will say the points ABC are collinear under what? 6 root 5. I'm sorry, 6 root 5. Under what? B dash, A dash, C. Now this last part of the question is what not all the boards will ask. Not all the boards will ask, but whosoever asks, this is what the answer is. We show them via a simple diagram, a segmental diagram, and write down what is the collinearity. B dash, A dash, C. Are you getting me, children? And if those who are thinking that, sir, if this value is not equal to, the points are not collinear, mind you. Only and only when the sum of the other two, sum of the two smaller one is equal to the larger one, then and then only they are collinear, otherwise not. So what is the condition for collinearity in coordinate geometry with the help of distance formula? Answer is, find out all the three distances, sum up the two smaller. If it is equal to the larger, the points are collinear, otherwise the points are not collinear. Right? Same thing, but by slope. So let me first write down the same thing here also. If we are taking this as a separate question, let A, which is 1 minus 3, x1, y1, B, 2 minus 5, x2, y2, and that of C, minus 4, 7, x3, y3. Now what is the condition with the help of slope? Out of the three, sir, which three are you talking about? Again, AB, BC, AC. Out of the three, you can find out slope of any two. Out of the three, you are supposed to find out slope of any two. AB, BC or AC. If the slopes are same, we have already learned something called as condition for parallel lines. If the slopes are same, people might think, students might say, sir, they are parallel to each other. That's what we have learned in the previous videos also. But I'm not yet finished off. Out of the three, find out slope of any two. If the slopes are same, moreover, they have one point in common. Not only their slope should be the same, they should have one point in common. If they have same slope and they have one point in common, the points are collinear. If they have same slope, out of the three, any two, and they have one point in common, the points are collinear. So let's say what I'm going to find out. I'm going to say AB and BC. I'm going to find out AB and BC. So what's the slope of AB? Slope of AB. Slope of AB is nothing but, we are aware, y2 minus y1. I hope my children are very well versed with the slope formula, which we have just done. So if not, refresh your concepts, go back, see the condition for parallel lines, right? And then solve this particular sum. Slope AB, y2 minus y1 upon x2 minus x1. What is y2, children? y2 minus 5 minus y1 minus of minus plus 3 upon x2 2 minus 1. Answer is minus 5 plus 3, 2 by 1, which is 2. Slope of AB, equation number 1. What I'm going to do now, slope of BC, same lines also. Slope of BC, this time mild change, y3 minus y2, x3 minus x2, y3 7 minus of minus 5 plus 5, x3 minus 4 minus 2. Answer is 12. I'm so sorry, here it is minus 5 plus 3 is minus 2. I'm sorry, it's minus 2. Minus 5 plus 3 minus 2 by 1, which is minus 2. 12 by minus 6. Answer is minus 2. So slope of BC is minus 2, equation number 2. Is slope of AB equals to slope of BC? Indeed. Do they have one point in common? Yes. What is that point? B. So those who say, sir, had I gone for AC, then still I'll be having one point in common? Yes, children. You are free to take any two. I shall make you understand before I complete my solution. If I take AB and BC, B is common. If I take AB and AC, A is common. If I take BC and AC, C is common. You have to have one point in common. So the slopes has to be same of any two, one point in common. Here, can I say from 1 and 2, slope of AB is equals to slope of BC, and they have common point in terms of what? Common point B. Therefore, points A, B and C are collinear. The only thing is, we won't be able to gauge in this kind of sum where we happen to find out with the help of slope who lies between whom, betweenness. Here we were able to get the betweenness. Here we won't be able to, but as I said, most of the board will not ask you the betweenness part, will not ask you this. They will ask you only the points are collinear or not. So either by distance formula or by slope. What is the condition for slope? Out of 3, any 2. You need to find out slope of any 2 part segment, and they need to have 1 point in common. I hope my children have understood both the ways of finding slope.